They ask me the same question all the time. As a theoretical physicist, when will we finally witness something in the cosmos that can't be explained? My answer used to be simple. Not yet. But that answer changed the moment a dim speck of light entered our telescopes last July. A faint, fast-moving object crossing the orbit of Mars. That speck is now known as 3I Atlas. This object didn't come from the asteroid belt, or the Kuiper belt, or even the farthest edge of the Oort cloud. It came from beyond, from the interstellar void, a place between stars so empty, so cold, that light itself takes centuries to cross it. And this visitor is not behaving like anything we've ever observed before. At first, astronomers dismissed it as another long-period comet. But within days, orbital calculations proved something astonishing. 3I Atlas was not bound to our sun. It was on a hyperbolic trajectory, meaning it would pass once and never return. That fact alone makes it historic. Only 2 other confirmed interstellar objects have ever entered our solar system. 1I Oumuamua in 2017 and 2I Borisov in 2019. Both were brief, mysterious guests. But 3I Atlas is different. It's brighter, more active, more stable, and above all, more puzzling. When it was first detected by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Hawaii, its velocity was measured at more than 210,000 kilometers per hour relative to the Sun. That's beyond anything native to our system. The object was moving so fast that nothing could capture it gravitationally, not Jupiter, not the Sun itself. By late July, powerful observatories, including the Hubble Space Telescope, Webb, and multiple ground-based arrays, locked their focus on this strange traveler. What they found broke nearly every model in the playbook. Instead of acting like a normal comet, one that warms, vents gases, and wobbles under the thrust of its own jets, 3I Atlas displayed 0 measurable deviation in its path. Despite violent outgassing, its orbit stayed perfectly steady. That alone defies Newtonian expectations. Every comet releases jets that push it slightly off course, but this one? Nothing. It's as if something inside it is stabilizing the motion, correcting every small perturbation in real time. Some researchers argue it's coincidence. Others whisper about active control. Let's start with what we know.
The estimated mass of 3I Atlas is enormous, roughly 33 trillion kilograms. That's enough to make it one of the densest interstellar bodies ever measured. Its surface shows highly reflective regions interspersed with dark silicate patches, suggesting a mix of metallic and carbon-rich material. Spectroscopic analysis from Webb reveals unusual compounds, crystalline silicates, hydrated minerals, and traces of nickel, but almost no iron. In natural cosmic formation, iron and nickel appear together. The absence of one is hard to explain without invoking processes far more complex than ordinary condensation in a protoplanetary disk. Then comes the outgassing itself. In early September, as it approached within 2 astronomical units of the Sun, the comet began ejecting massive plumes of gas and dust, including carbon monoxide and carbon dioxide. But again, the motion didn't change. Something was compensating for every burst. And the story only grows stranger. Most interstellar visitors we've seen arrive at random inclinations, from above or below the plane where our planets orbit. But 3I Atlas entered almost perfectly aligned with the ecliptic, the same thin, flat disk that defines our planetary orbits. That coincidence borders on impossible. Out of every direction in space, this object arrived in the single orientation that allowed for a prolonged observational window. Some say it's luck. Others call it design. And then there's its solitude. Large natural bodies almost never travel alone. Jupiter has its Trojan asteroids. The Kuiper belt hosts entire families of related debris, but 3I Atlas came utterly solo. No fragments, no companions, no gravitational siblings. It's as though it was expelled alone, or built that way. During its closest solar approach, late October 2025, a powerful solar flare erupted from the Sun, classified as X-class, one of the most energetic types. The shockwave should have stripped dust, fractured the surface, or at least changed the brightness pattern. But when the flare hit, 3I Atlas remained completely intact. No fragmentation, no loss of structure, not even a noticeable thermal stress signature. It's as if the material it's made from, whatever it is vastly more resilient than ice or rock. Something engineered for endurance. Polarization data adds yet another layer.
When sunlight bounces off cosmic dust, it becomes polarized, twisted in a measurable way. Every comet ever studied produces a positive polarization pattern, but 3I Atlas exhibits a deep negative polarization curve, more extreme than any known object. Only polished metallic surfaces or engineered crystals behave that way. That's 5 anomalies already, and there are more. Photometric measurements show the light from 3I Atlas fluctuating rhythmically, as if it's rotating. But the pattern doesn't match the wobble of a rough, uneven rock. Instead, it's precise, regular, almost mechanical. The estimated aspect ratio, length to width, may be as high as 12:1, making it long, narrow, and stable, reminiscent of Oumuamua's cigar shape, but even more pronounced. Natural objects rarely form like this. They spin apart, they crumble, they erode. But this one holds together perfectly, even under thermal stress. If you were designing an interstellar probe meant to survive for millennia through gas, dust, and radiation, this is exactly the shape you'd choose. Streamlined, minimal cross-section, optimized for long-term travel. All of this raises an uncomfortable possibility. What if 3I Atlas is not simply a comet, but a construct? A probe camouflaged as a comet, hiding in plain sight among billions of natural wanderers. The logic is sound.
If an advanced civilization wanted to explore star systems without alerting their inhabitants, they wouldn't send bright, beeping spacecraft. They'd send objects that blend in, inert on the outside, silent, untraceable. Cometary camouflage, an ancient cosmic Trojan horse. If that's the case, its purpose could vary. Perhaps it's passive, an observer carrying miniaturized sensors, quietly recording radio emissions, mapping atmospheres, and monitoring magnetic fields. Or perhaps it's active, carrying payloads meant to interact with planetary systems, microscopic probes, nanotechnological seeds, even catalysts that alter the chemistry of young protoplanetary disks to foster life. Directed panspermia, a concept once confined to science fiction, suddenly feels less far-fetched. Consider this. In March 2026, 3I Atlas will make a close approach to Jupiter, using the planet's immense gravity for a slingshot maneuver. If it were natural, that's coincidence. If it's engineered, it's navigation. A gravitational assist is exactly how our own spacecraft gain speed without burning fuel. Now imagine something using that technique not by accident, but by design. During the same window, from October through December 2025, a series of unexplained communication gaps appeared across several NASA data streams. Officials cited partial shutdowns and technical delays. The European Space Agency, however, continued observations through Mars Express and Trace Gas Orbiter, collecting high-resolution spectroscopy that has yet to be released in fall.
Independent observatories from Chile to Japan continued to track the object. Radio telescopes scanned for emissions. None were reported publicly, but the data is still being analyzed. The urgency is clear. After December 19, 2025, the object will begin receding toward interstellar space. This is humanity's last real chance to study it up close before it disappears, possibly forever. If this sounds dramatic, it is. Because in the vast history of astronomy, opportunities like this almost never come twice. And yet, amid all the data and science, a deeper question looms, one that shakes the foundation of our understanding of existence. What if we are being tested? Not attacked, not invaded, just evaluated. What if 3i Atlas isn't just observing the solar system, but observing us, watching how we respond to evidence of something that doesn't fit our models? Do we dismiss it? Do we panic? Or do we finally admit that the universe might be teeming with intelligence, older, quieter, and vastly more advanced than we are? It's not the first time humanity has sent its own messages into the void. Voyager 1, Voyager 2, Pioneer 10, and New Horizons, all 5 are now beyond the solar system, carrying our identity encoded on metal plates and golden records. We've shouted our existence into space. Maybe this is the echo.
Scientists like Avi Loeb of Harvard have suggested we treat every interstellar visitor as a potential artifact. Not because we assume aliens, but because testing that hypothesis is good science. If it's natural, we'll know. If not, we'll have found something that redefines civilization itself. As Loeb said, when you see a duck and it walks like a duck and it quacks like a duck, you call it a duck. If an object moves like a spacecraft, stabilizes like one, and behaves unlike any natural body, maybe, just maybe, that's what it is. Others, like NASA's planetary defense teams, take a more cautious approach. They emphasize that extraordinary claims require extraordinary evidence. But even they admit the physics of 3i Atlas don't add up neatly. The implications stretch far beyond science. If 3i Atlas is artificial, it could be ancient, millions of years old, a relic drifting between stars long before humans evolved, a technological fossil of a civilization long gone. Or it could be current, still functional, part of an automated network of probes traversing the galaxy, exchanging information silently, unseen. In either case, the result is the same. We are not the first to cross the stars. And that realization changes everything. Because for centuries, humanity has looked up at the night sky and wondered if we're alone. But maybe the real question isn't whether life exists elsewhere, it's whether life ever stopped existing. The cosmos is old, unimaginably old. Civilizations could rise, master physics, vanish, and leave behind only objects like this one, silent, durable, anonymous. Perhaps 3i Atlas is one of many. Perhaps others have already passed unnoticed. We've seen comets for thousands of years, after all, streaks of light crossing the heavens, omens to ancient eyes. How many were just comets, and how many were something more? The paradox is that we may never know.
Unless we study relentlessly, unless we demand transparency from the agencies collecting the data, unless every byte, every pixel, every photon captured from this object is released openly for the world, for the species. Because if this is what it appears to be, if we are truly witnessing technology from another star, this moment belongs not to one country or one institution, but to all of humanity. And if we're wrong, then we've still advanced the frontier of science. We've asked harder questions, refined our models, and prepared ourselves for the day when the answer truly is artificial. But the clock is ticking. 3i Atlas is speeding away, deeper into the light of the sun, soon to vanish beyond the reach of even our best telescopes. After December, it will fade, and all that will remain is data, debate, and an echoing question. What did we just witness? Was it a natural traveler from another star? Or was it something else? Something sent, not born? If we choose skepticism, we risk missing history. If we choose belief, we risk self-deception. Somewhere in between lies the truth. So keep your eyes on the sky this year. Watch the news feeds. The story of 3i Atlas is still unfolding, and when the last signal fades,
When this strange object vanishes back into the eternal dark, remember this moment. Because for the first time in our species' history, the question, are we alone, isn't just philosophical anymore. It's observational, it's measurable, and it's passing right in front of us. The instruments are live, the world is watching, and the universe may finally be answering.